Okay, thank you for tuning in, and in today's session we'll be looking at practical network security. So we'll start by looking at DNS, how it works, and then we'll take a look at HTTPS, which is basically comprises of SSL, TLS, and finally the HTTP portion of it. So these are some of the more common protocols, the bread and butter that you have to understand. Okay, so in today's session we will actually assume that the network has already been connected, and then we are looking at all the subsequent activity from there onwards. And then the first thing we are going to do is we're going to run ipconfig. And then we will have some parameters, the IP address and the gateway and things like that, which we can use to fill in into our network. Okay, so let's take a look at our home network. Okay, taking a look at our home network, we can immediately see that our IPv4 address is 192.168.10.162. And let's assume that we are using our laptop here. So immediately we know that this is 192.168.10.162. And then we can see what is our default gateway. So the default gateway is normally your home router. So your home router here would be 192.168.10.1, and this is the default gateway because all internet traffic or all traffic would be going out through the home router, and that's the gateway for you to access the internet. So normally your desktop and all that will be on the same subnet. So it might be 10. Let's say 163, 10.164 and things like that. And this is how actually a home networking actually works. So if we take a look further down in our network diagram itself, we have multiple ISPs, and these ISPs are all peered. So they will often take the shortest path in order to route the packets. And then we would have our corporate network here. So just for the sake of this example, we assume that this is Google, because we are going to be visiting Google later. So imagine that this is Google's network, and then they have firewalls, they have web servers, file servers, email servers, switches, employee laptops, and everything like that. Okay, so all the ISPs are actually all linked up to each other, and then there will be multiple home users that are connected, home networks. So it's actually over here, it's actually abridged already. We've actually made it very simple. In fact, it should look like what's happening at the top, but because of space constraint and we don't want to make it too complex, so we'll just link it immediately. And of course, some of the routers are serving multiple commercial customers at the same time. So there may be multiple corporate networks here, and for simplicity's sake, we'll just link it to a single server. Instead of having too many corporate networks, but it may all look similar to this. Okay, so we have already established the very first setup, and we know how the traffic actually goes up. So imagine now we are trying to visit google.com in our web browser. What's going to happen first is we would actually need to do a lookup, a DNS lookup, and that would DNS will actually give us the IP address that the domain name belongs to. And how this is done is we would actually let me go into Ubuntu instead, and let me do an NS lookup for google.com, which is the domain we are looking for. And immediately we know that google.com, we can see a whole bunch of 142.something addresses in here. So how does this look like in our network map? We are actually querying our DNS server. So we may have a DNS server, some people have a Pi-hole or something like that, a DNS server at home, but most of the time if you're not technically savvy, you may be using your ISP's DNS server, or even people like Google, they may have a DNS server themselves as well, 8.8.8.8. So assuming that for today we're going to be using our ISP's DNS server, so what's happening is that our DNS request is coming out from here. Can you tell me who is google.com? It's going to the ISP, and then the ISP DNS server is returning to you the response. So you're asking, google.com, this is the request, and the response that is originating from that is 142.250.something.something. All this would actually go back to you, to your browser. So your browser knows that in order to visit google.com, you should be going to this address 142.250.4.113, and so on and so forth. So you get the whole list of addresses here, and then your browser will just randomly pick an address and visit it. Okay, and that part of the visit will actually be done using SSL TLS already. So you start the handshake to start the encrypted connection. So how do we actually visit this 142.250 subnet here? So for all of these ISPs, they would have various routes. So for example, this one here, this ISP here will know that anything that is 142.250.something.something, it should go in this direction here. Okay, and possibly in this direction here, it may be other kinds of subnets. So it could be 140, this one could be 141, and so on and so forth. And so what happens that when you try to visit 142.120, the packet would come to your router, it will come to your ISP, and your ISP will have a routing table, which is the most direct route to hit 142. And your ISP will tell you that it's via ISP D. So it will come here, And then ISPD also will have multiple routes, and they will know that 142 would be bound for here. And you come to the firewall, and since it is on port 443, SSL and TLS is on port 443, so you come to Google's web server. And then there will be the key exchange that's taking place, and then the certificate. So what will go down first would be the certificate here. So the certificate of google.com would actually go down here. Okay, so we are jumping ahead a little bit at this point in time. So what I'm going to do now is I'm going to curl google.com, and then we can take a look at what's happening here. Okay, so we can immediately see when we curl google.com, the first few lines, the same thing is happening. It's resolving the IP address, the domain name to the IP address. Okay, and then it's picking something randomly, and that's what we've said earlier. Okay, and then now we can see the TLS handshake, the client hello. So the certificate comes down, and then it is actually checking against our certificate root here, CA certificates.crt. So these are all the roots, the roots that are already in our home laptop here. And you check the root will normally sign an intermediary, and we can see over here, certificate level 0, level 1, level 2, somewhere here, and then the intermediary will actually sign, the cert that comes down from Google itself. And then once we are happy that this is indeed google.com, it's not someone that is masquerading, pretending to be google.com, okay, we would actually go on to complete the handshake, and then we would start with the HTTP traffic that is within that tunnel itself. And then we can see what comes down, what happens in here is HTTP is happening already. So we can see get, get, post, and all these are HTTP verbs. So we are getting, google.com. And immediately we can see these are the contents of google.com. So it's telling us that it's this is actually all the headers that are in here, and then what's telling us is this is the content that it has moved, and we should be visiting https google.com/ over here. Okay, and what's happening is that after we are happy with all of that, http / get / all the way here to the web server, and the web server responds with this 301 moved, and it goes all the way back to the source, and then this is how it gets displayed on our web browser. And in a nutshell, this is how DNS, HTTP, and finally you get the web page itself.